These two players have played 10 matches in all. Who's better? Here's the comparison of their performances.
Looking at the average, player 16 is definitely better.
Welcome to the lesson on the mean of grouped data. At the end of this lesson, you will be able to define the mean of grouped data. You will also be able to calculate the mean of grouped data using the direct method, the assumed mean method, and the step deviation method. Meet Miss Greenfingers. She is actively involved with the tree plantation programs in her city, but looks like something is troubling her. Here is the data for the tree plantation program that Miss Greenfingers recently conducted in 60 schools in her city. Now she has to find the average number of trees planted in each school. Let's help her to do it. First, let's observe the table carefully. What does it represent? The table shows the data for a tree plantation program as a grouped frequency distribution table. To find the average number of trees planted in each school, Miss Greenfingers has to find the mean of this grouped data. Recall that the mean of a given set of data is equal to the sum of the values of all the observations divided by the number of observations. There are three ways of calculating the mean: the direct method, the assumed mean method, and the step deviation method. Let us learn about these methods in detail. Let us begin with the direct method. What do the two columns in this table represent? The first column represents the class interval of group data, and the second column represents the frequency for each class interval. The first step to finding the mean of grouped data using the direct method is to find the class mark for each class interval. Let's denote the class mark as xi. The xi for each class is equal to half the sum of the upper and lower class limits of each class interval. Using the formula, we can calculate the class mark for each class interval. The class mark for the first class interval is equal to half the sum of 5 and 25. That is, half of 30, which is 15. Similarly, the class mark for the second class interval is 35. The remaining class marks are calculated and given in the table. Next, let us find the product of the frequency and the class mark for each class interval. This is denoted by Fixi. Now observe carefully how we calculate the value of Fixi. As you observed, for the first class interval, Fixi is the product of 12 and 15, which is equal to 180. Similarly, for the second class interval, Fixi is 280. The remaining products are shown in the table. Now, let us find the sum of the products of the frequencies and the class marks for all the class intervals. This sum is represented by summation Fixi, which is equal to 3300. We are close to finding the solution for Miss Greenfinger's problem. The mean x-bar of this grouped data is equal to the sum of the products of the frequencies and the class marks for all the class intervals divided by the sum of all the frequencies. On calculation, we get the mean of the given grouped data as 55. Thus, the average number of trees planted in each school is 55. We arrived at this result by calculating the mean of the given data using the direct method. This method involves a lot of multiplication and addition. This method can be tedious if the class intervals and frequencies are large. Let us see if there is a simpler way to find the mean of group data. let us go back to the data table. We'll take up from the step where we calculated the class marks for the class intervals in the given data. We'll try using a different method, the assumed mean method for finding the mean. This method can also be used when the size of the class is not the same. Observe the class marks for different class intervals. Let us assume any one of these class marks to be the mean of the given data. Let's choose 35 as the assumed mean denoted by A. Now, let us find the difference between the class mark for each class interval and our assumed mean. We'll term it as deviation and denote it as DI. The deviation for the first class interval is 15 minus 35, or minus 20. Similarly, for the second class interval, the deviation is 35 minus 35, or 0, and so on. Now, let us find the product of the frequency and the deviation for each class interval. This is denoted by FI/DI. For the first class interval, this product is 12 multiplied by minus 20, which is equal to minus 240. Similarly, for the second class interval, this product is 0. The product for the remaining class intervals are calculated and shown in the table. Next, we'll find the sum of the products of the frequencies and the deviations from assumed mean for all the class intervals. This sum is represented by the Greek symbol summation and read as summation. In this case, this sum represented by summation FI/DI is equal to 1200. Now, let us see how we can use this value to find the mean of the given grouped data. For this, we will have to derive a formula. Let's consider the summation FI/DI. Since DI is equal to xi minus a, we can substitute this in the above equation. Next, we'll divide both sides of the equation by summation Fi. The right side of the equation can be expressed as follows. Since summation Fi/xi divided by summation Fi is equal to the mean x bar, let's rearrange the equation. Here, x bar is the mean, a is the assumed mean, and summation Fi/DI divided by summation Fi is the mean of deviations. Thus, we arrive upon a formula where the mean of the given data is equal to the sum of the assumed mean and the mean of deviations. Now, let's use this formula to calculate the mean of the given grouped data. Substituting the values and calculating, we get the mean of the given grouped data as 55. This method is called the assumed mean method to find the mean of grouped data. Thus, we see that the mean found using the assumed mean method is in agreement with the value of the mean found using the direct method. Now, let us see if we can further simplify the calculations using another method to calculate the mean of grouped data. Let us go back to the step in the assumed mean method, where we chose one of the class intervals as the assumed mean and found the deviations for all other class intervals. We'll rework from here using a different approach. Observe the class intervals in this table carefully. Note that the class size for all the class intervals is 20. The class size is the difference between the upper class limit and the lower class limit. It is denoted by the letter H. Now, for each class interval, let us divide the deviation from assumed mean by the class size. This value is denoted by UI. The value of UI for the first class interval is equal to minus 20 divided by the class size 20, which is equal to minus 1. Similarly, for the second class interval, this value is 0. The remaining values are shown in the table. Now, let us find the product of ui and the frequency fi for each class interval. This is denoted by fiui. For the first class interval, this product will be equal to 12 into minus 1, which is equal to minus 12. Similarly, for the second class interval, this value will be 0. The remaining values are provided in the table. Now, let us add the products of fi and ui for all the class intervals. This value summation fiui in this case comes to 60. Now, let us see how we can use this value to find the mean of the given grouped data. This involves a bit of derivation. Let us start with the relation we found in the assumed mean method. Since ui is equal to di divided by h, we can say di is equal to the product of ui and the class interval h. Substituting this value in the equation, we find a relationship between the mean x bar, ui and h. Further substituting in the values, we find that the mean of the given grouped data is 55. This method is called the step deviation method. It is also used to find the mean of grouped data. Thus, we see that the mean found using the step deviation method is in agreement with the value of the mean found using the assumed mean and the direct method. Welcome to the lesson on the mode of grouped data. At the end of this lesson, you will be able to define the mode of grouped data. You will also be able to calculate mode of grouped data. Miss Greenfinger's heart beats for the trees. She recently conducted a tree plantation program in 60 schools of her city. Now, why is she looking so hassled? Actually, Miss Greenfingers is preparing a project report. She has to find the maximum number of trees planted across all 60 schools. Now, what does this mean? Look at this example. The data for 6 schools is given here. Which value representing the number of trees planted is repeated frequently? Note that 6 trees are planted in one school, 2 trees are planted in 2 schools, and 4 trees are planted in 3 schools. In this case, 4 is occurring the maximum number of times. Now, coming back to Miss Greenfinger's data, let's help her find the maximum number of trees planted across all 60 schools. She has the grouped data of all 60 schools that participated in the tree plantation program. Observe the data presented in the grouped frequency distribution table. To find the maximum number of trees planted across the 60 schools, Miss Greenfingers has to find the mode of this grouped data. Recall that the mode of a given set of data is the observation with the maximum frequency. Now, let us find the solution to Miss Greenfinger's problem. The table represents the class interval of the grouped data and the frequency for each class interval. The first step towards finding the mode of the grouped data is to locate the class interval with the maximum frequency. In the given data, the maximum frequency is 20. The class interval corresponding to the maximum frequency is called the modal class. Here the modal class is 65 to 85 as it corresponds to the maximum frequency of 20. The mode of this data is calculated using the formula shown here. Now, let us find what each term in this formula represents. In the formula for mode, L stands for the lower class limit of the modal class. In this case, the value of L is 65, which is the lower class limit of the modal class 65 to 85. The H stands for the class size. While finding the value of H, we assume that all class intervals have the same class size as in the case of this table. Here the value of H is 20. Next, in the formula, F1 stands for the frequency of the modal class. In this case, the modal class is 65 to 85 and its frequency F1 is 20. Moving on in the formula for mode, F0 stands for the frequency of the class preceding or just before the modal class. In this case, the class preceding the modal class is 45 to 65 and its frequency F0 is 14. Finally, in the formula for mode, F2 stands for the frequency of the class succeeding or just after the modal class. In this case, the class after the modal class is 85 to 105 and its frequency F2 is 6. Now, let's substitute the values of L, H, F1, F0 and F2 in the formula for calculating mode. Let's simplify this expression further. The mode of a given data is equal to 71. Miss Greenfinger's problem is solved. The mode or the same number of trees planted in maximum number of schools as per the given data is 71. You've reached the end of this section. Before moving on, let's review the key points covered in this section. The mode of a given set of data is the observation with the maximum frequency. The class interval corresponding to the maximum frequency is called the modal class. The formula to calculate the mode is as shown. Here, L stands for the lower class limit of the modal class. The H stands for the class size. F1 stands for the frequency of the modal class. F0 stands for the frequency of the class preceding or just before the modal class. F2 stands for the frequency of the class succeeding or just after the modal class. Welcome to the lesson on the median of grouped data. At the end of this lesson, you will be able to define the median of grouped data and explain the concept of cumulative frequency. You will also be able to calculate the median of grouped data. Ms. Greenfingers is actively involved with the tree plantation programs conducted in her city. Here is the data for the tree plantation program Ms. Greenfingers recently conducted in 60 schools. The data is shown as a grouped frequency distribution table. Ms. Greenfingers has to find the median of this group data. Recall that the median of a given set of data is the observation that lies in the middle of the data. Observe the grouped frequency table. What do the two columns in this table represent? The first column represents the class interval of the group data, and the second column represents the frequency for each class interval. Now, observe the class intervals in the first column. Each class interval has a lower class limit, highlighted in yellow, and an upper class limit, highlighted in blue. Next, we'll rewrite the number of trees planted using only the lower class limits of all the class intervals. We can write the first class interval, 5 to 25, as more than or equal to 5. Similarly, we can write the second class interval, 25 to 45, as more than or equal to 25, and so on. Now, observe the number of schools in the frequency column. Will the frequencies remain unchanged, or do these frequencies need to be adjusted as per the new class intervals? From the new class intervals, it is clear that all the schools have planted at least 5 or more than 5 trees. Thus, the adjusted frequency of the first class interval is the total number of schools, which is equal to 60. The adjusted frequency for the second class interval is not 8, but 48. Similarly, the adjusted frequencies for the remaining class intervals are calculated. This new adjusted frequency is called the cumulative frequency. Now, let us combine this table with the original table showing the actual class intervals. The table here now represents the cumulative frequency distribution of the more than type. There is one more type of cumulative frequency distribution. Let's see how it is calculated. Now, we'll rewrite the number of trees planted using only the upper class limit of all the class intervals. The first class interval, 5 to 25, can be written as less than 25. The second class interval, 25 to 45, can be written as less than 45. The other class intervals can also be rewritten similarly. Now, observe the number of schools in the frequency column. Here too, the frequencies will need to be adjusted as per the new class intervals. From the new class intervals, it is clear that 12 schools have planted less than 25 trees. Hence, the adjusted frequency for the first class interval remains 12. However, the number of schools that planted less than 45 trees is the sum of the frequencies of class intervals less than 45 and less than 25. That is, 12 plus 8, which is equal to 20. Thus, the adjusted frequency of the second class interval is 20. Similarly, the adjusted frequency for the third class interval is equal to 12 plus 8 plus 14, which is equal to 34. This adjusted frequency is also called the cumulative frequency. Now, let us combine this table with the original table showing the actual class intervals. The table here now represents the cumulative frequency distribution of the less than type. Preparing a cumulative frequency distribution table is the first step for calculating the median of the group data. You can use the cumulative frequency distribution of either the more than or the less than type to find the median of grouped data. Now, we'll use the cumulative frequency distribution of the less than type to find the median of the number of trees planted. The first step is to find half of the total number of observations. The total number of observations is given by the sum of all the frequencies and denoted by n. In this case, n is equal to 60. So, half of the total number of observations is equal to n by 2, which is equal to 30. Note that to calculate n, or n by 2, we use the frequency and not the cumulative frequency data. The next step is to locate the median class. The median class is the class interval with the cumulative frequency more than and closest to the value of n by 2. In this case, n by 2 is 30. The cumulative frequency of class interval 45 to 65 is 34, that is, more than and closest to 30. Thus, 45 to 65 is the median class for this data. The median of grouped data is calculated using the formula shown here. Let us see what each term in this formula stands for. The L in the formula for median stands for the lower class limit of the median class. In this case, L is equal to 45. The N in the formula for median stands for the total number of observations. In this case, N is equal to 60. The symbol CF in the formula of median stands for cumulative frequency of the class preceding the median class. In this case, the median class is 45 to 65 and the class preceding it is 25 to 45. This class has a cumulative frequency of 20. Thus, the value of CF in this case is 20. The symbol F in the formula of median stands for frequency of the median class. In this case, the median class is 45 to 65, and its frequency of value F is 14. The symbol H in the formula of median stands for the class size of class intervals in the given table, assuming all class sizes are equal. In this case, the class size H is 20. Putting in the values of different terms and calculating, we get the median of the given data as 59.28. We have found the answer to Miss Greenfinger's problem. Now she can say that around 50% of the schools planted less than 59 trees, while the other 50% of the schools planted more than 59 trees in her tree plantation program. You have reached the end of this section. Before moving on to the next section, let's recap the key points covered. The median of a given set of data is the observation that lies in the middle of the data. The cumulative frequency of a class is obtained by adding the frequencies of all the classes preceding the given class. There are two types of cumulative frequencies, the less than type and the more than type. Preparing a cumulative frequency distribution table is the first step in calculating the median of the group data. The cumulative frequency distribution of either the more than or the less than type can be used to find the median of group data. The formula for the median of grouped data is shown here. In this formula, L is the lower class limit of median class. N is the total number of observations. Cf is the cumulative frequency of class preceding the median class. F is the frequency of median class. H is the class size of class intervals. Hope you enjoyed your learning experience. Welcome to the lesson on the graphical representation of cumulative frequency distribution. At the end of this lesson, you will be able to define an ogive, also called a cumulative frequency curve. You will also be able to draw ogives for the less than and the more than types of cumulative frequency distributions. Miss Greenfingers has recently completed a tree plantation program for the local schools in her city. In all, 60 schools participated in the program. She has the data of the number of trees planted during the program in a frequency distribution table. Here, the first column displays the class intervals and the second displays the frequency. Can we represent this data graphically? Yes, we can. Recall that you have learned to represent group data using bar graphs, histograms, or frequency polygons. Let's see another way of representing this data. First, class intervals are rewritten using lower class limits only. Next, their corresponding frequencies are adjusted as shown. Now, we have the cumulative frequency distribution of the more than type. Similarly, the cumulative frequency distribution of the less than type is prepared. For this, the data is first reorganized using only the upper class limits of the class intervals. Then, their corresponding frequencies are adjusted as shown. The cumulative frequency distribution of the less than type is obtained. Next, we'll see how this reorganized data is represented in a graphical form. Let's first consider the cumulative frequency distribution of the more than type. This data, if represented graphically, results in a curve, which is called an ogive or a cumulative frequency curve. An ogive is defined as a curve that represents the cumulative frequency distribution of grouped data. To draw an ogive for this data, we will need a Cartesian plane. Here, we'll plot the lower class limits of the data on the x-axis and their corresponding cumulative frequencies on the y-axis. Let's choose any comfortable scale to mark the lower class limits on the x-axis. We'll take a scale of 1 centimeter equal to 10 units, which is equal to 10 trees on the x-axis. Then, we'll label these with the lower class limits of the class intervals. Next, we'll choose a suitable scale to mark the reference points for the cumulative frequency on the y-axis. We'll take a scale of 1 centimeter is equal to 5 units, which is equal to 5 schools on the y-axis. We can label the x-axis as lower limits of data, or simply as lower limits, and the y-axis as cumulative frequency. Next, we'll mark points on the graph that represent the cumulative frequency corresponding to the lower limits of the class intervals. For example, for the lower limit of 5, the cumulative frequency is 60. Similarly, we'll mark the points corresponding to cumulative frequencies of the other lower limits of data. Finally, we'll draw a smooth curve to join all the points marked on the graph. This curve is a cumulative frequency curve, or ogive. Since in this case, the ogive represents a cumulative frequency distribution of the more than type, it is called a more than ogive. Now, let's draw an ogive representing the cumulative frequency distribution of the less than type. The table here shows the cumulative frequency distribution of the less than type. Let's start plotting the ogive for this data. Here's the Cartesian plane. To draw a less than type ogive, we'll plot the upper class limits of the data on the x-axis and their corresponding cumulative frequencies on the y-axis. We'll label the x-axis as upper limits of data or simply as upper limits. Next, label the y-axis as cumulative frequency. Next, we'll choose a scale to mark the upper class limits on the x-axis. Here, we'll take a scale of 1 centimeter equal to 10 units, which is equal to 10 trees planted. Next, we'll choose a suitable scale to mark reference points for cumulative frequency on the y-axis. Here we'll take a scale of 1 centimeter equal to 5 units, which is equal to 5 schools. Next, we'll mark a point above each upper limit of data on the x-axis corresponding to its cumulative frequency on the y-axis. For example, for the upper limit of 25, the cumulative frequency is 12. Similarly, we'll mark the points corresponding to cumulative frequencies of other upper limits of data. Finally, draw a smooth curve to join all the points marked on the graph. Here's the required ogive. It is an ogive of the less than type. Ogives can also be used to find the median of grouped data. Let's see how this is done. From this table, we can see that the total number of observations of the value of n for this data is 60. So n by 2 is equal to 30. Now, let's locate the value of n by 2 on the y-axis. We'll draw a line parallel to the x-axis from the point denoting n by 2 to intersect the ogive. From this point of the ogive, draw a line perpendicular to the x-axis. The point where the perpendicular intersects the x-axis gives the median of the grouped data. As you can see, you can use either the more than or the less than ogive to find the median of the grouped data. In both cases, the median of the given grouped data is approximately 59. There is another way of finding the median of the grouped data using the ogives. We can draw both the less than and the more than ogives on the same chart. The two ogives will intersect at a point. Draw a perpendicular to the x-axis from the point at which the two ogives intersect. The point where the perpendicular intersects the x-axis gives the median of the grouped data. Note that, by this method, the median of this grouped data is also approximately 59. You have reached the end of this section. Before moving on to the next section, let's recap the key points covered. An ogive, or cumulative frequency curve, is a curve that represents the cumulative frequency distribution of grouped data. An ogive representing a cumulative frequency distribution of the more than type is called a more than ogive. An ogive representing a cumulative frequency distribution of the less than type is called a less than ogive. Ogives can be used to find the median of grouped data. The median of grouped data can be obtained graphically by plotting the ogives of the less than type and the more than type. The x-coordinate of the point of intersection of the two ogives is the median of the grouped data. Hope you enjoyed your learning experience.